Hello, my name is Ludwig Seitz from the Swedish Institute of Computer Science, which is part of the Research Institutes of Sweden, RISE. This demonstration is going to be about the fine-grained authorization enabler feature, authorization and authentication for resource-constrained devices based on ongoing IETF standardization. And in order for you to better be able to appreciate the demonstration, there's a short presentation first that explains what is going on in the demo. The motivation or the problem we want to solve is a constrained server that provides some service. In this example, for example, a valve that is regulated. And we have a client that wants to connect to this server and make a request, for example, set a new setting or read the current setting and then get a response. And the scenario we want to prevent is an attacker getting unauthorized access to that server. And we are assuming that the server, being a constrained device, has intermittent connectivity, which means it can't contact third-party services to verify the client's authorization. It needs to do that on its own. Our solution is based on IETF standards, first of which is the Auth 2 standard for access control, and a profile of that standard called ACE that adapts it to constrained environments. So in this solution, we introduce a trusted third party, the authorization server. And this authorization server is in a step that happens before the actual access. It's configured by the resource owner with access control policies that tell the authorization server which client has the right to access which resources on which servers. When this previous step has been performed, we can go on to normal access procedures, and they are modified as follows: that the client first actually goes to the authorization server instead of directly contacting the server and submits a request for authorization. The authorization server verifies the client's request against the policies that were previously configured, and if the policies authorize that request, it will issue an access token, which is a signed data object that the client can use to prove that it actually has the right to access the resource. In a third step now, the client will send this access token to the server for further future use. And we assume that this is short-range communication, for example, via Bluetooth or NFC or another short-range communication protocol. After the token is sent to the server, the client can now send its request, and the server will then, in a fifth step, verify that this token is from a trusted authorization server and that it indeed authorizes the client's request. And if that is the case, it will provide a response. So now to the demo. I have here a little window showing the view of a client. And in this demo, everything is running on my machine. But the demo can, of course, be deployed in the test bed on different machines. So it's just for convenience of the presentation that I have everything in one computer. So first of all, our client is going to send a request to the resource server without being authorized. And what we get back is some feedback. Please note everything that is shown in this window back down here is actually pretty printed, human readable data. The actual data send is encoded in a binary format, which is much more compact and much less readable for humans. So that's why I implemented a lot of pretty printers for this demo. So what we get back from the resource server is that the client is unauthorized to perform this request. And furthermore, we get back a hint as to which authorization server the client should contact in order to obtain an access token. So in the next step, we're going to get our access token. And what we're sending to the client is a number of, to the authorization server is a number of parameters that define what kind of access we want to perform. So in this case, we are trying to access an audience called resource server 1. And we're using a grant type client credentials. That's Auth thing. It basically means that in this type of authorization token request, the thing that authorizes us, that grants us the token, is just our client credentials. There are other grant types in OAuth where you have a specific grant, an explicit grant. The scope describes what kind of access we want to do. So in this case, we want to read a Hello World resource. And the format of the scope is entirely application specific. So the application needs to understand what it is. The last parameter here is for confirming the possession of this token. So we're asking the authorization server to bind this token to the following key. And this confirmation parameter contains an elliptic curve public key. So in this case, we're asking the authorization server, please bind this key to the access token you're going to issue to me. And what we receive back from the authorization server is an access token in an encrypted and signed format. And we also get another parameter, which is a key for the resource server so that the client can authenticate it. In this case, also an elliptic curve public key. In the next step, we will then send this newly received access token to the resource server. And that's very simple. The resource server validates it, and if it's a valid access token, it replies only that it has stored the access token with the following identifier, so that the client can later refer to it. So in this case, the identifier is 0000 in hex. Now we have established our token at the resource server, so we're going to send our request again. And our request is authorized, and we get back some content, namely Hello World. This was the demonstration. Thank you very much.